Let's start with the hospital supplied equipment. This equipment includes your standard surgical instruments and an endoscopic tower. The endoscopic tower includes a monitor, a camera box, a light box, and an insufflator. The insufflator is connected to the hospital CO2 supply. It is what keeps the tunnel open during the endoscopic procedure. The insufflator attaches to the endoscopic equipment by CO2 tubing. The light box generates light for the endoscope. One end attaches to the light box, and the other end attaches to the endoscope. The camera box is what generates the image. The camera head attaches to the camera box. The camera head has a coupling device here for the endoscope, also has a focusing and a zoom. The camera, the light, and the CO2 tubing all go on the sterile field and should be sterile, or they should be covered by a sterile sheath. Your hospital's equipment might differ a little bit than what you see here, but all the components need to be available for the endoscopic procedure. Next is the GETINGE reusable equipment. This includes the endoscope, the power supply, the adapter cable, and the extension cable. The GETINGE endoscope is an extended length 7mm 0-degree scope. It is made specifically for our endoscopic kits. The distal end has a threaded area that connects with our dissection tip. And on the proximal end is the connection for the light cable, which has adapters for multiple light leads, and for the universal mount of the camera. The power supply is what gives current to our harvesting tool. It has a power supply knob, has an area for electrical plug, has an on-off switch, and has an attachment area for our adapter cable. When the on-off switch is on, the LED green light is on. The adapter cable connects to the power supply on one end and the other end connects to the extension cable. The extension cable is a universal end cable. Both ends are the same. One end goes to our cutting tool, the Hemopro 2. The other end is connected to the power supply. The power supply and adapter cable are non-sterile and usually reside on the endoscopic tower. The extension cable and the endoscope are used in the sterile field and are to be sterilized for each case. This is GETINGE's disposable kit. Inside this kit is equipment for the dissection portion of the procedure, as well as the transection portion. The dissection portion includes a 30 cc syringe, a blunt tip trocar, a dissection tip, and an additional cannula seal. The dissection tip screws on to the end of the endoscope, and this is what's used for dissection. The blunt tip trocar goes within the incision to create a seal for the CO2 tunnel. It has a clear tubing for proximal CO2 insufflation with a one-way valve. It also has a port to inflate the balloon. The balloon can be inflated with up to 25 cc's of air to create a better seal on the incision to maintain CO2. The BTT is used for both dissection and transection. During dissection, the smaller holed endoscope seal will be used. And during transection, the larger hole cannula seal will be used. In the remaining part of the tray is the transection equipment. This equipment consists of the Hemopro 2 cutting tool, the cannula, and a 3 cc syringe. The Hemopro 2 cutting tool cuts and seals vessels in one easy step. The activation toggle on the handle controls the jaws. To open the jaws, you would push the activation toggle forward. To close the jaws in the middle, and to activate the device, you would pull completely back. The Hemopro cutting jaws have a concave side and a convex side. The concave side is the side with maximum insulation, and that's the side that should be facing the main vessel. On the convex side is a spot cautery, which can get hot with activation, and that should be facing away from the main conduit. The Hemopro 2 cutting tool is connected to the power supply at the handle. There are arrows on the handle and arrows on the extension cable to click and place. Prior to using this in a case, you should test that the circuit is complete. To do so, you would take a sterile, moistened gauze, place it within the jaws. Close the jaws by pulling the toggle back, and then pull all the way back to activate the jaws. At this time, steam should be generated. That indicates there's a complete circuit. As you can see here, the thermal image shows the Hemopro 2 cutting a branch. On the concave side, there's very little thermal spread, and on the convex side, there is an area of red where the spot cautery exists. Next, I will talk about the cannula. The cannula has two ends, the handle end and the distal end. The handle end has two ports, one where the endoscope goes in, here, and two, the Hemopro 2 port. It also has two tubes. One is clear with a one-way valve, and that's for the CO2. The other is blue with a one-way valve, and that's where this 3 cc syringe, once filled with saline, can be attached for scope washing. The C-ring slider controls the C-ring that's on the distal end. The endoscope should first be placed within the handle of the cannula, and then the Hemopro 2 jaws should be closed and pointing up and placed within the cannula. The distal end is where the distal CO2 comes out and where the Hemopro 2 cutting tool comes out. It can be retracted and advanced independently as well as rotated 360 degrees. The C-ring comes out at an angle. The C-ring protects the main conduit by cradling it away from the cutting tool. The C-ring and the cutting tool have a common relationship. The C-ring and the cutting tool always are in the same alignment with the cutting tool being behind the C-ring. Also, the C-ring comes out at an angle. The further the cutting tool and the C-ring are, the longer the branch length. The safest distance when cutting branches would be with the C-ring and the cutting tool as far apart as possible. And this is the cannula with the cutting tool in it. Now that we've reviewed all of the components, let's see how they work together on our leg model. We have our endoscope. We'll attach the endoscope to the camera head. Focus and white balance will occur, and the light cord will be attached to the light post. The dissection tip will be attached to the end of the endoscope, and the BTT will be placed onto the endoscope. After the incision has been made and the vein has been found, you will place the dissection tip on top of the vein and travel about 4 centimeters in. Then you can place the BTT within the incision. The CO2 is attached and can be started to flow, maintaining the CO2 tunnel. As seen in this image, you will travel anterior to the vein to the length that's needed. You will then come back, do posterior, and clean off the side branches. Once that portion is complete, the endoscope will be removed from the leg. The dissection tip will be removed from the endoscope, and the endoscope will be placed within the cannula. Your cutting tool will be placed within the cannula. And your CO2 will be transferred from the BTT to the CO2 of the cannula. The cannula seal will replace the endoscope seal on the BTT. Your scope wipe syringe will be on the blue tubing. The connector for the Hemopro 2 will be attached. Now your equipment is all set up for transection. You will then enter into the BTT, into the tunnel you created, and using your C-ring and your cutting tool, you will start ligating branches as seen on this image. Once all the branches are cut and the vessel is free from any connective tissue, that's when the transection would be complete and you would remove the vein for bypass surgery.